Hi and welcome. Today we'll be doing what is a fraction review. We'll be covering concepts like improper fractions and mixed numbers, simplifying or reducing fractions, and then creating equivalent fractions. Again, this is a review, making sure that we're ready to go through and cover all of our Algebra 1 content, including what happens when we see things like mixed numbers and fractions within the confines of an equation that we have to solve. I know a lot of people get tripped up when they see those fractions, and I want to make sure that we have enough understanding and know how to complete these. So the first thing I want to look at is, what is a fraction? A fraction is a part of a whole. So if I have 1 out of 2, then 2 made up the whole, and one of them is a part of it. Fractions are always less than 1. That's what makes them not a whole number. However, when you put a whole number out in front of a fraction and add a whole number to it, for an example, 5 and 1/2, we have 5 wholes, but we're not all the way to 6, we're halfway. We have a half in there. And so looking at mixed numbers means that there's a whole number and a fraction put together. Now, there is a way that you change the mixed number to an improper fraction. What an improper fraction means is that the number on top is actually larger than the number on the bottom. When the number on top, the numerator, is larger than the denominator, the number on the bottom, it actually is not less than 1. It's actually a whole or many wholes plus some extra. And so that makes it an improper form. So for an example, how would I take this mixed number and make it into its improper form? Well, I have a method here where we start at the bottom in the denominator, and what we're going to do is we're going to go clockwise. So I draw my arrows in this way to remind myself I'm going around, almost like in a circle. So I start here and I'll do times first. 2 times 5. Well, 2 times 5 is 10. And then what I'm going to do is take that product and add it to the numerator. 10 plus 1 is 11. Now let me switch markers because this looks terrible. So I had 2 times the 5 is 10, plus the 1 I had here in the numerator. 10 plus 1 is 11. Now I have the correct numerator for my improper fraction. One thing to remember is that denominators always stay the same. So the bottom number is always there. One of the ways that I like to help people to remind this is that I say we started from the bottom, now we're here. We started from the bottom, the 2 stays the same. Started from the bottom, now we're here. So where are we on the top? We went through a process to get a larger top than the bottom. We did that again by starting here on the bottom, the denominator where the 2 is, and going around in a circle to get to the top. I do that by a series of times, so 2 times 5, and then plus 10 plus 1. We'll try that in one more example. So let's say I had 7 and 3/4. I'm going to start on the bottom, times going around, so 4 times 7 is 28, and then I'm going to add that top number. 28 plus 3 is 31. I started from the bottom, now I'm here. But what's on the bottom? Again, the exact same start. So the denominator always stays the same when we're going and changing our mixed numbers to improper fractions. Another thing we want to look at is simplifying or reducing fractions. Simplifying or reducing is a very, very important skill. The reason this skill is so important is because you can go through an entire math problem, solve an equation, what have you, but if you didn't reduce or simplify to the lowest terms, you're probably not going to get that answer correct on a test. It will still be an equivalent form of the fraction, but if the directions specifically say to simplify or reduce, you won't get the right answer if you only have a larger equivalent form. So what I'd like to do is take a look at a very simple problem. I have 2 over 6. Most people can go ahead and simplify this and get 1/3. But how how do we get 1/3? Well, what you have to do is find something called the greatest common factor, also known GCF is what that stands for, greatest common factor. If you do not find the greatest common factor from the start, that is okay. All that means is that you would not have found the most simplified form after you're doing your reducing. You would still have an equivalent form. What you want to do is continue simplifying until you found your most simplified form. So how would I find the greatest common factor between the two? My simple method involves this. If your fraction is a proper fraction, meaning the numerator is smaller than denominator, take the numerator, the number 2. Write it off to the side if you're not very good with facts or factors. And write the factors. Well, the only factors of 2 are 1 times 2. So the largest number there is the 2. I want to see, does this also go into my denominator? Well, yes, it does. 2 goes into 2 and 2 goes into 6. So I'd use that as my greatest common factor. So I divide both numerator and denominator by this number 2. 2 divided by 2 is 1. 6 divided by 2 is 3. Very simple problem. But what happens when we make the numbers larger and you may not feel confident about the factors of that number? I'm going to pull one here. Let's call it, this one says 16 over 64. Now you may already know the largest number that can go into both of them, a greatest common factor. However, I like to go through in my mind, pull 16 out to the side, again because that's the smaller of the two, and list the factors. Well, I know that 1 times 16 is 16. I know that 2 times 8 is 16. And I like to list them all in order to make sure I found them all. Well, 3 times anything get me to 16? No, 3 doesn't work. What about 4 times anything? Yes, 4 times 4 actually gets me, 4 times 4 gets me to 16. If I have been going in order 1, 2, I tried the 3, the 4, as long as you're going in order from 1 up, once you see a number duplicated, if you notice 4 happens twice on my list, I know I have found all of them. I'm going to show you that in another example. So here, now that I have found the factors of the first one, I know that every single one of these numbers works for 16. But I need to figure out which one of these numbers also works for 64. Now, if you are not certain and you don't want to start with 16, maybe you don't have a calculator available, or maybe you're not very good at long division, whereas you would see, does 16 go into 64 this method? Now, if you're not comfortable with this, use the calculator. I'm going to show you in case you do not have a calculator. I would look at this and say there's 2 digits out here, 2 digits in here. How many times, roundabout, can 16 go into 64? I'm going to say, well, maybe probably about 4. Well, 4 times 6 is 24. 4 down, carry the 2. 4 times 1 is 4. Plus that 2 up there is 6. I actually got it right the first time. The number 4 of 16 goes into 64 4 times. So I know that this 16 works for 64 as well. Well, that makes it quite easy now to divide both the top and the bottom by that greatest common factor. 16 divided by 16 is 1, and 64 divided by 16 is 4. I don't have to do that math again because I just did that math right here. That's why it's important to be sure you're making sense of what's going on when you're solving problems. If you did 64 divided by 16 and you got an answer of 4 times, that means 4 times 16 is 64. Likewise, 64 divided by 16 is 4. I do see a lot of students figure out the greatest common factor, and then when they go to do their division, they do the math all over again. Please trust yourself when you do the math the first time and make sense of the answers that you got. So here we have our most reduced form or simplified form of 1/4. I want to show you one last example of what happens if you did not find the greatest common factor from the start. It's okay, like I said. It just means you want to continue your steps until you get there. So for an example, I have 24 over 30. Some people can look at this and automatically decide what would be a greatest common factor. Some people will come across, list the factors like I mentioned, start at the largest one, and start seeing which one also goes into your denominator of 30. When I look at this, the first thing I notice is I can keep dividing this by 2 because both of these numbers are even. So I'm going to chop them in half. Well, 24 divided by 2 is 12. 12 is half of 24. And 15 is half of 30. So 30 divided by 2 is 15. So what I did was I used 2 to do my division here. 2 is not my greatest common factor, and I know that because now when I look at 12 over 15, I notice that this can still be reduced more. And what can I use here? Well, the first thing I say is, well, I know that 12 times 3 is 4, and that 15 times 3 is 5. So I knew that if I divided 12 divided by 3 and 15 divided by 3, that I would have got 4/5 as a final answer. So 4/5 is now its most simplified term because there's nothing I can do besides continue to divide by 1 to get anything smaller than that. So I did 2 different rounds of simplifying here, but for me it happened very quickly because I already knew I could chop these in half and I already knew I'd have numbers I could easily recognize. If you do not have numbers you easily recognize, my recommendation would have been to come over here, put the 24 and list all the factors like I showed in the previous 2 examples. Now, that covers the simplify and reduce, but I want to keep this problem up here to show you a little bit about equivalence. Here I look, and this 24 over 30 is equivalent to 4/5. It's also equivalent to 12/15. This means if you were to have a bar of shaded areas and each one was broken up into a certain amount. So let's say this one was broken up into 4/5. That's 5 parts there. That means 4 of these parts would be shaded. 4 of the 5 are taken up. The similar thing here, if I was to break this one up into 15 parts, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I were to shade 12 of them. So I'm going to come down, 1, 2, 3, shading all 12 of them. Look at that. It's just about the same height because it's the same quantity of the parts, but it's just written differently. There's more slats here than there are here to be colored in. I'm not going to complete the one here for 30 because I just don't want to draw a bunch of lines and color them in. But I can tell you already that when I color this one in, 24 over 30, it will also be just the same 4/5 amount. So what if it's not written in a visual form, but you needed to solve something like this? 24 over 30 is the same as what over 12 over 15? Well, this is where I would work a little bit backwards, and I would look and see, okay, well, I'm going to use it like this. Well, I look at what I do know. What I do know is they gave me a pattern from 24 to 12. And I need to think, how would I get from 24 to 12? Oh, I probably divided it in half. That's what it looks like they did, divided it in half. 24 divided by 2 is 12. Excellent. So then I know what to do to the bottom because in fractions, you want to do the same thing to the top and the bottom when we're talking about equivalence and reducing. So I would say 30 divided by 2 is 15. and now I have found my number. Another way to look at this would have been to say, okay, what over 5? Well, 12 over 15 is equivalent to what number over 5? The fast way to figure out that is to see, what do I know? Well, I do know that they took me from 15 to 5. So can I find the relationship or the pattern there to get from 15 to 5? And I can. I recognize that 5 times 3 gets me to 15, or that 15 divided by 3 gets me to 5. So as long as I do the exact same thing on the top, numerator, I will have my answer. So I will say, what times 3 gets me to 12, or 12 divided by 3 is 4. Just another way to find the same answer. However, I want to show you in this example one last part. If I took all of this part away, I can still show equivalence here. I'm going to take the 5 off, and I would say, okay, if I had 24 over 30 is equivalent to 4 over what number? We already know the answer is 5. We've done this problem for a few minutes now. But let's find the relationship or pattern. How could we get from 24 to 4, or from 4 to 24? I have to be familiar with multiplication facts and division facts. Well, I know that 4 times 6 is 24. 24 divided by 6 is 4. So 6 is that common number there. So I will do the same thing, either divide or divide by 6 here. So 30 divided by 6 is 5. Does that work? Yes, because 5 times 6 is 30. So I wouldn't have had that middle step if this was the problem, 24 over 30 is equal to what, 4 over what. This is how you find equivalence. You have to look and see, what do you know, what is the relationship or pattern, and do that to the numerator or denominator, whatever the number is that's missing. Such a brief review of improper fractions to mixed numbers, back and forth, simplifying or reducing fractions, and then finding equivalent fractions. That covers presentation station 1 on this week's fraction and integer review cover sheet. You can check off presentation station 1, and you can start sections 1, 2, and 3 on the worksheet that has been provided. Now, if you are watching this on video, I will try to provide a link to the worksheet if you'd like to practice for yourself, as well as the answers on the website after about another week or so when my class is finished with it. So for my class period, sections 1, 2, and 3 should help you out. This video should help you out to complete those. Please feel free to comment, ask any questions that you may have, or send me a message or comment at YouTube, Miss Kite. See ya.